Hello, I'm Gheehyun NAHM, who will give a talk under the title Interesting Mathematics. I think the title is somewhat vague, and I should first clarify what kind of mathematics I'll talk about, and what kind of mathematics I find interesting. I find a mathematical statement or proof interesting if it teaches me a new intuition or if it corrects an intuition I had. So for instance, some mathematical facts such as that the sum of two odd numbers is even looks easy, and it is actually easy. So this is definitely not one of those mathematical facts I want to talk about in my talk. But usually interesting mathematical facts might look easy, so I don't really want to give an example because it might spoil my talk, but it might not be easy in reality, or it might even be false. In this case, the intuition you had, which told you that this statement looks very trivial, is wrong, and it'll tell you a new intuition and correct your original intuition. Or sometimes your intuition might say that it looks hard, impossible, or even false, but it might be true. And sometimes it might even have a very short proof, which might be illuminating and gives you a new intuition, which will help you think about these kind of things or any problem related to this. So in my talk, I will try to introduce at least two, one from each of these two categories, two mathematical facts and the proofs of them. And if time permits, I'll talk about a few more. So in this remaining 3-ish minutes, I will give some interesting problems which might or might not have to do with the problems I'll talk about in my talk later on. So one is the following. So there are two mathematicians, and each mathematician, let's say A and B, each mathematician will be given a random hat, either red or blue. And they cannot see their own hat, but they could see the other's hat. And at the count of 3, simultaneously, they will have to guess what color their hat is. But they could come up so that in any circumstance, in any situation, at least one of them has to get right. But even though they can come up with a strategy beforehand, but they cannot exchange any information once their hats are given. So could you come up with a valid strategy for them? So maybe you want to pause the video and think about it for a few minutes or a few seconds. So the answer is actually not very hard in this case, so the answer is follows. So one answer might be A just shouts out whatever color B is wearing, and B guesses whatever color A is not wearing. So for instance, if A and B both are given a red hat, then A will shout, "Oh, I think I'm wearing a red hat," and B will say, "Oh, I'm wearing a blue hat," and in this case, A will get right. So the actual problem is, what happens if you have n mathematicians instead of 2 and n colors instead of 2, and the rest remains the same? Could you come up with a valid strategy, or is this just impossible? And the second problem I want to introduce is the following. So you consider the integer grids in 2 dimensions, and I will define what a path is. So for me, a path is you go along in integer points like this, but you cannot traverse diagonally. So like you can't do this, but you can do whatever you want aside from that. So I say that your path contains a cycle if some part of it bounds an area. So for instance, this thing bounds an area, this area. So this in fact contains a cycle, and this also contains a cycle, and so on. So the question I really want to ask is the following. So you start from a cycle in 3 dimensions, so you do the same thing. For instance, this is a cycle in 3 dimensions along the integer points. And then if you have a cycle, could you find, so since you have 3 ways of projecting it onto one of the planes, one of the coordinate planes, say x, y, y, z, or z, x, if you have a cycle, can you choose one of these projections to find a cycle in the projection? So to clarify what I'm saying, for instance, in this case, if you project it to the zx plane, then the projection doesn't contain a cycle. But if you project it to the xy plane, then it contains a cycle. In fact, it's just a cycle. So can you find this kind of projection in general? So can you choose one of the 3 projections given a cycle in 3 dimensions so that the projection contains a cycle? So you could think about these 2 problems until the talk, and I might talk about one of these, or I might talk about something related, but this hopefully will occupy you for until the talk and might set this stage up for my talk. Thank you for listening, and see you in a few weeks. Bye.